planet has experienced monumental events that have shaped the way life on Earth has evolved. "300 million years ago, amphibians and primitive life forms lived in the seas. 200 million years ago, marshes dried up and dinosaurs roamed the Earth. 70 million years ago, the earliest primates walked the Earth. About 65.7 million years ago, dinosaurs became extinct as the result of a catastrophic extinction event. About 5 million years ago, the earliest humans appeared. This is Early Man, Part 2, Ancestors of Modern Man. A little more than 2 million years ago, the first species of the genus Homo appeared. These creatures were all of the same genus, Homo, but theoretically did not interbreed with each other because they were of different species. These included Homo habilis, Homo erectus, Homo ergaster, Homo rudolfensis, and others.
One of our big problems in understanding the human fossil record is the fact that we're the only species of hominid in the world today. And this seems to be very right and very natural because it's what we're used to.
Dr. Ian Tattersall, curator at the American Museum of Natural History, New York.
But in fact, it's very unusual in the longer-term history of the human family. And it has been normal for several hominid species to be around in the world at the same time.
Those who study early man sometimes have specialties within paleoanthropology, like the evolution of speech.
When did it occur? How did it occur? Why did it occur? Are great mysteries that we don't know. But we're getting some interesting clues.
Dr. Jeffrey Laitman, professor of anatomy and cell biology, Mount Sinai School of Medicine, New York.
The clues are coming from early members of our own genus, Homo.
Others have different specialties. Dr. Ralph Holloway is an expert on the evolution of the human brain.
It seems obvious that there has to be some relationship between brain size and intelligence, at least in the paleontological perspective.
Dr. Ralph Holloway, professor of anthropology, Columbia University.
But what do you do with a modern perspective? Because there are populations that do differ in terms of their brain sizes. But we have no indication that they differ significantly in their intelligence.
Most paleoanthropologists are simply trying to put all the puzzle pieces together.
We used to believe that evolution was a fairly regular process, and we now see that evolution is a very irregular process.
Professor Gail Kennedy, Department of Anthropology, UCLA.
There's lots of branching, and we see periods with lots of evolutionary activity going on. We call these pulses, when lots of new species suddenly appear. And it's during this period that species appear to be experimenting with local resources, trying things out, trying out new ways to survive.
Scientists have discovered that there's something magical about 2.5. That is, 2.5 million years ago on Earth's timeline. At that point, there occurred a flurry of evolutionary activity unlike anything before or since. Several species of early man were living at the same time. The stage for this activity was Africa.
2.5 million years ago was an incredible event in human history. We see a great deal of things happening at 2.5. Cause of all this appears to have been the start of the ice ages. In the northern hemisphere, the first of the ice sheets were forming. and glaciers would soon extend out from these centers in Europe. In Africa, climate suddenly got cooler and drier. And while there had been forests covering Africa for all of its earlier history, at 2.5 these forests suddenly broke up and began to disappear. And with this, grasslands appeared. Serengeti, which everyone pictures when they think of Africa today, dates to this event, to 2.5 million years ago. Vast open spaces opened up. And this climatic change did essentially two things. It increased competition for forest resources, so it was tougher to live in the forest where animals had first evolved. And second, it opened opportunities in these new grasslands, and many animals moved out into the grasslands. And so very quickly, at 2.5 million years ago, we see two new kinds of hominids.
At about 2.5, I think we can make a good judgment that there are probably 3 or 4 species of hominids there, and most likely at least half of them are from the robust lineage.
We see the robust Australopithecines making an adaptation to eating grasses and seeds and grains, the highly abrasive foods that are common on the grassland. And we also see Homo, the first members of our own genus, using stone tools. So stone tools also date to this magical period of 2.5.
Stone tools came on the scene about 2.5 million years ago, and we frankly have no idea about the identity, the exact identity of the hominids who made them.
The first tool maker may have been an Australopithecine, or it may have been an early member of the genus Homo. We certainly don't have enough information now to make a decision between those two choices.
But by 2 million years ago, probably several different kinds of hominids were making tools and sharing the landscape between them in some ill-defined way. We don't know exactly how these early hominids 2 million years ago shared the landscape among themselves. But we do know that they were all there and presumably had some small behavioral differences among themselves which allowed them to coexist.
Well, at 2.5, we see a great deal of evolutionary activity, and we very quickly see at least 3 species within the genus Homo. Homo habilis is probably the best known of these new species. Homo ergaster and Homo rudolfensis also all appear in East Africa in a very short period of time.
One of our big problems in understanding the human fossil record is the fact that we're the only species of hominid in the world today. And this seems to be very right and very natural because it's what we're used to. But in fact, it's very unusual in the longer-term history of the human family. And it has been normal for several hominid species to be around in the world at the same time. In northern Kenya, about 2 million years ago, there were at least 4 hominid species not simply on the same continent, but on the very same landscape. So we need to we need to adjust to this notion that we were not alone in the world, and that if we are alone in the world today, it's an exceptional situation.
Today, we are the only human species on the planet. This was not always the case. Dr. Tattersall explains how we define a human species.
Species are reproductive groups. That's how they're defined. The species is the largest reproductive unit that there is. If 2 individuals are unable to breed successfully with each other, they are considered by definition members of different species.
Evolution used to be portrayed as a ladder, as a very simple progression, and now it's very messy with lots of branches going off to the side, lots of lateral groups.
What may be confusing is the diversity of the human race that we see today, from Aborigines to Scandinavians, from Pygmies to Eskimos, from Asians to Indians. But these do not constitute different species. We're all Homo sapiens.
Well, it's all Homo sapiens because you have, dogs are simply an example, not a good example because they're domesticated, they're artificially bred and so forth, of how much variety that you can get within a species. And Homo sapiens is another example of that. You can get a lot of sort of local, superficial differences emerging within the species without speciation intervening, without the process of production of new species. These are two unrelated processes. The production of new species and production of new variants within the species are two different things entirely.
Returning to our timeline, at about the same time in pre-recorded history, 2.5 million years ago, the ice ages began, producing not one, but many periods of climatic fluctuations from cold to warm and cold again. This occurred during the Pleistocene epoch, which ended some 10,000 years ago. Some scholars argue that it has not ended and that we are still in the ice ages, with another glaciation to come. Early man existed and thrived during these ice ages. The most favorable climate for man, however, were the warmer zones near the equator. Most scientists now agree that human life originated in Africa. The temperate equatorial climate of its grasslands made it an ideal home. Some call the continent Mother Africa. Some of the most significant fossil discoveries have come from East Africa, and specifically a region called the Olduvai Gorge in Tanzania. Beginning in the 1930s, Lewis and Mary Leakey spent years searching for remains in this fertile area.
This is the skull that was found by Mary Leakey at Olduvai in 1964, and it was originally called Zinjanthropus, which is the Kikuyu name for East Africa, and it has since been named Australopithecus boisei. This is a robust form of Australopithecine, and it dates to about 1 3/4 million years ago. This is in fact one of the first fossil humans to be radiometrically dated, so we have a very precise date on this fossil.
Yeah, there is an iconic significance both of the of Olduvai Gorge itself and of the activities of the Leakey family. It turns out that Africa was the birthplace of humankind. Exactly where in Africa, we don't know, but Africa is where humankind emerged, and the Leakeys have been involved since the very beginning in the uncovery of the early history of humans in Africa. It's a very important role.
One of the Leakey family's most famous finds at Olduvai was the remains of Homo habilis. It's been theorized that this was the first known species of our genus, Homo. On our timeline of early man, Homo habilis occupies a period in prehistory that dates from 2 to 2.3 million years ago. The facts surrounding all distant relatives of modern man are subject to controversy. Experts disagree on many points regarding the various fossil evidence. One thing they tend to agree on, however, is that the use of stone tools occurred first around 2.5 million years ago.
Absolutely. If you look at a picture of one of these very early stone tools, they're little flakes about this long and with a sharp edge. And they don't look very impressive, but experimental archaeologists have managed to butcher entire elephants using just these very simple flakes. So they were effective. They were effective and basically remained unchanged as a technology for well over 1 million years.
There's a great deal of missing information about our ancient relatives, and this frustrates the scientific community.
There's a huge amount that is not known in paleoanthropology, and essentially that is where novelists have to take over from scientists, because frankly scientists don't know everything. They don't have the evidence that they would like to have to interpret the lifeways of early hominids. So there are lots of puzzles left. We don't know how many fossil species, extinct species of hominids there were. We'll probably never know that for sure. How they divided up the landscape and the resources between them, we don't know that either. There's a huge number of unanswered questions, but we can't conjure those answers into existence. We have to work with the material we have.
It's difficult to talk about physical characteristics of early man. Just like modern man, some individuals were small, some were larger. But generally speaking, earliest Homo were small, no more than 5 feet tall. On average, maximum weight was only about 110 pounds. But by 2 million years ago, some were as much as 6 feet tall. The lower jaw and teeth reveal a more modern curve and smaller molars than his predecessors. His diet probably consisted of vegetation, meat scavenged from the kill of other animals, and small game that he hunted and killed. Most importantly, they had a larger brain than Australopithecus, 650 to 800 milliliters, but still only half the size of modern man's brain.
What we're seeing on this table is the fossil record that we have for human evolution that goes back to about 4 million years at that end of the table, with a form we call Australopithecus afarensis, and we come all the way up through Australopithecines, through early Homo erectus, Homo habilis, and Homo ergaster. We come to early archaic Homo, and then we hit Neanderthals, and finally we come up to what we see as modern Homo sapiens here.
To illustrate how difficult it is to differentiate species characteristics from simple distorted or damaged fossil remains, Dr. Holloway compares 6 skulls.
Now, one of the things that we know is that in our own species, our form of the skull is very variable, and we have to take that variability into account. I'll bet when you look at these, you would be prone to think of these two as different species, or different species from this one here. That would be incorrect, because all 6 of these skulls are exactly the same species. What we have here, for example, is a modern Australian aborigine. What we have here is a fossil form that did come from the cave of Chaokutian in China, but this is about 12 to maybe 15,000 years old. Okay, it's very modern in its form. We have here a modern Caucasian male. This is a modern Japanese. This is a cast, of course. We think this is modern Negro, or black and black American. And this is an artificially deformed skull that came from either Mexico or Peru, I'm not positive which, in which head wrapping, taking place in an extremely early age, is constant, and so the skull is deformed and grows in this posterior direction.
When Homo habilis remains were first found in the early 1960s, there was a loud outcry over calling this species the first of our genus. Dr. Holloway tells us what we've learned since then about the genus Homo.
This was OH7, these marvelous parietals, which were then reconstructed using mirror imaging techniques. All of these are somewhat different in terms of their morphologies, and it would appear that at this early juncture in human evolution, when we're dealing with the appearance of Homo, that there might have been a mini adaptive radiation. That is, different forms fingering out into slightly different ecological niches and taking somewhat different advantages of those differences. And maybe what we're really sampling in this early part of the record for early Homo is an adaptive radiation. Some are going to carry through and become Homo erectus or become Homo ergaster somewhat later, and they are eventually going to become Cro-Magnon further down the line.
Further discoveries in the 1970s gave us more information about early Homo. Some of these were made in the Kubifora area of Kenya, east of Lake Turkana. This famous cranium, known as KNMER 1470, with a brain size of 750 milliliters at the time, was thought to be Homo habilis. Ironically, today more and more experts are coming to the conclusion that the skull represents yet another early species of Homo, Homo rudolfensis.
This is the endocast of KNMER 1470, the famous 1470 that was found by Richard Leakey. And I had the honor of making the first brain endocast from those skull fragments back in the mid-70s. And what you see here is I've made a reconstruction of the base. The cranial capacity came out to about 752 cc's on this one. But what was of great interest to us was the fact that it showed this occipital protrusion in the left side and also an increase of width of the right frontal, which is, we think, clear evidence of handedness in that animal.
More fossil evidence found at Turkana and also at South Africa's Sterkfontein, dating back 1.6 million years, provided further knowledge about early Homo. Another important species of the genus Homo is ergaster, which means workman. Ergaster dates to 1.9 million years ago. It, too, was found in East Africa and is thought by some experts to be the first to venture out of Africa.
Currently, we think that it was Homo ergaster who was the first to leave Africa. We see evidence for Homo ergaster both in Europe and probably in Asia very soon after 2 million years ago. And it appears that both in Europe and in Asia, Homo ergaster may have given rise to new lineages of humans in both of those areas.
The next step up the evolutionary ladder brings us to Homo erectus. This species in the genus Homo, although more recent than Rudolfensis and ergaster, was discovered 70 years earlier. It was a young Dutch doctor, Eugène Dubois, who discovered Homo erectus at Trinil, Java in 1891.
The story of Eugène Dubois is a very extraordinary one because in 1889 or thereabouts, Dubois went out to Indonesia with the avowed intention of discovering the fossils of early man.
Eugène Dubois was a young man in Europe when a scientist named Ernst Haeckel published the first family tree in 1889. And at the base of this family tree was an orangutan, indicating that the earliest humans were Asian in origin. So Eugène Dubois decided that he would go to Asia and find these earliest humans.
And, you know, this was an extremely long shot, and yet he discovered those fossils. And they were the only truly ancient hominid fossils known at that time. Being
rather poor, he didn't have enough money to go to Indonesia, the Far East, on his own. So he joined the army as a physician. And as an army doctor, he was able to explore various areas in Indonesia. And very quickly after his arrival in Indonesia, he found the first pieces, the first fragments of Homo erectus.
Dubois' initial finds included a thigh bone and this skull cap. The brain case was unlike anything that had been seen until then. The head of this individual, sometimes called Java Man, would have been long and low, with bony brow ridges. Further discoveries of Homo erectus fossils during the 20th century gave us a better picture of what he was like. Beginning in the early 1920s, fossils were found at Chaoqiu-Tien, not far from Beijing, China. The broken remains of about 40 individuals were found. One of these was the skull of Peking Man, discovered in 1929. 5 other similar skulls found at the same location all show the same basic features as Java Man, a member of the Homo erectus family.
Peking Man was another example of Homo erectus along with Java Man, and for a long time this was the best sample that we had of early hominids in this period, which we now know to be about 500,000 to 1.5 million years ago. Homo erectus was one species of a whole group that existed across the world in this in this time period, and was a local development. You only find Homo erectus in Eastern Asia. You don't find it anywhere else. All the things that have been called Homo erectus from further west in Asia or in Africa are in fact distinctive species. They don't belong to Homo erectus, but they belong to other species that may, well belong to the same group, but have separate evolutionary histories.
Homo erectus had a larger brain than his ancestors, 900 to 1,000 milliliters in volume, nearing the size of the average modern man's brain. At the Chaoqiu-Tien site, a Professor Franz Weidenreich, an anatomist, suggested that the human remains found in the cave were the results of cannibalism.
Cannibalism seems to be a behavior that is occasionally documented in the history of the human family, but it's relatively rare. I don't think that anybody would claim that cannibalism was a regular source of protein for any human group. Yes, it's something that happened from time to time, but it's not a major aspect of hominid behavior.
This then was home to Homo erectus, based on current knowledge. Fossil remains have been found in Africa, China, and Java. There is no evidence these species lived in Europe. But again, paleoanthropology is a work in progress. In the 1970s and 1980s, some amazing discoveries were made in East Africa. In 1975, this nearly complete skull was discovered in the Lake Turkana region of Kenya. It dates to 1.7 million years ago. The brain case is 750 milliliters in size. The skull is named KNMER 3733 and is thought to belong to the species Homo ergaster. Dr. Jeffrey Layton evaluates his ability to speak.
This individual comes from the shores of East Turkana in Kenya and is known as 3733. We know our fossils by numbers. This specimen has many portions of the skull base intact, and we measure it and look at it, you'll be even able to see that you're starting to get this angulation or bending of the bottom of the skull. So what this is saying to us, what this fossil is speaking, is saying that the throat region was starting to change. When we've reconstructed this specimen, what we have come to is that we believe the specimen would look different from the earlier monkeys and apes. Here we're looking at the reconstructions of the throat region of this early ancestor from East Africa, and we have reconstructed the soft tissues. Due to the slight bending of the skull base, we believe the voice box would be lower in this individual than you found in our friend from South Africa, Mrs. Ples. Things were beginning to change with our early members of our own genus. Sometimes from 2 million years onward, our voice box was starting to shift. It was starting to go down. This meant that a number of changes would occur. Number one, we couldn't breathe and swallow simultaneously anymore. We were gaining the ability to choke to death. It was starting when we were on the African plains. We were also starting to get more of an area of space above the larynx to modify sounds. So these individuals clearly had crossed some important Rubicon. They had left the confines of ape-like grunts and growls for the more mellifluous tones of human beings. But they were not yet there. They were not yet us.
When early humans began speaking, what was it they talked about?
Well, that's the great question in the evolution of human language. What did they want to talk to each other about? What did they have to converse about? The one thing that language gives you is the ability to talk about the past and the future, to reminisce about things that have happened, maybe to figure out what went wrong in a particular incident and to learn from it. Also, it gives you a future. You can plan. You can think about things in advance, maybe where the next hunt is going to occur, where you're going to move to next. So this gives you a great latitude in your intellectual life.
Also in the Lake Turkana region of Kenya, another important discovery was made. This almost complete skeleton of a young boy, also Homo ergaster, who lived about 1.6 million years ago.
Turkana boy skeleton is a skeleton of maybe a 9-year-old child who was 5'3" when he died and would probably have topped 6 foot as an adult. So he was pretty tall, and the first really good representative we have of a being with a modern human body form.
Fire was an element of the societal culture of early man. Gail Kennedy shares her thoughts.
Well, we think of the campfire having an advantage mainly of cooking food and keeping warm, but actually there are a lot of other advantages that are less obvious about the campfire. In one of my books, I made a comment, if I could read it to you. It says, "The social ramifications of the hearth are stunning. It provides a focus for activities. It defines both time and place for the exchange of ideas and information. Its light extends the working part of the day, so that tool making and hide preparation may be practiced and perhaps even improved over a longer span of time. And in addition to facilitating these activities, it provides a focus for leisure, during which activities not directly related to sustenance may be carried on. It's easy to see the beginnings of art and storytelling in such leisure."
About 100 years ago, fossils of another species of the genus Homo were found in Europe. The name given to this fossil, a jawbone, is Homo heidelbergensis, since it was found near Heidelberg, Germany. It was taken from a gravel pit in the small town of Mauer, Germany, near Heidelberg. Its approximate age is 500,000 years. A more complete skull was found at the mouth of a cave near Arago, France. It is a 400,000-year-old cranium of a young adult, found with some of the tools these early people used. Further evidence of Homo heidelbergensis was found at Bodo, Ethiopia. It may be well over 200,000 years old. The specimen would have been heavy in build with a robust face and large brain case. Another skull that may be heidelbergensis is from Kabwe, Zambia. Originally named Rhodesian man, this nicely preserved skull was found with a few bones of the body. He would have stood about 5 feet 8 inches tall. The brow ridges are pronounced, and the forehead slopes back dramatically.
This is Kabwe man. It used to be called Rhodesian man, which gives you an idea of where it was first found. Currently, most people believe that this is in the species Homo heidelbergensis, but there is a great deal of debate about which species this specimen belongs to. The most interesting aspect of this species, of this individual, is the enormous amount of dental disease that it shows. Dental disease, while it plagues modern humans, actually is a fairly recent addition to the hominid line. Most hominids had very healthy teeth, no decay, no periodontal disease, no need to visit a dentist. But this poor fellow had terrible dental problems. There's a great deal of decay. Some of these teeth have decayed down to the gum line. There are abscesses where the roots have actually protruded through the side of the jaw there. And this is the root of the canine here. And this may well have been the cause of death. This tooth, obviously from the evidence that remains, was very infected and undoubtedly very painful. And the root of this tooth would be in close enough proximity to the tissues that surround the brain to cause meningitis and cause death. And under a microscope we can actually see that this tooth was torn out. There are actually little bits of bone that have been lifted away as the tooth was torn out.
The cranium is large, with a brain size of 1,280 milliliters, which is close to modern standards. Kabwe man is about 200,000 years old. In Spain's Atapuerca Mountains, a cave was discovered that contained the fossil remains of a species of people that were among the earliest Europeans. The 43-foot deep cave apparently was used as a disposal site for the dead. Its name is Cima de los Huesos, which means pit of bones. The almost complete remains of 30 individuals were found, apparently unceremoniously thrown into the pit. Virtually all parts of the human skeleton were recovered, including the most delicate bones. They date back 300,000 years. One of the puzzling aspects of this discovery is that most of the individuals are adolescents and young adults with no obvious diseases. This artist's conception represents how they might have looked.
The site at Atapuerca is very important. It gives us some information that we've gotten from no other site. At this site, approximately 32 individuals were thrown down a pit, perhaps in some sort of burial procedure. What this told us, though, is the age profile of this particular population, and all of the individuals were very young. Only 2 of the individuals were past the age of 30, and most considerably younger than this. Most were dying before the age of 20. So this presents us with a paradox. Hominids take a long time to grow up, and yet adulthood in these fossil humans was quite short. Who's taking care of the children? Who is taking over the raising, the nurturing of the children who are left behind by these early deaths? And this tells us something about the social organization of these early hominids. Very likely, child rearing was a cooperative venture with several individuals, perhaps not even related, taking care of children who have lost one or even both parents. We see this same kind of behavior in a number of non-human primates. So this might be a very old trait in primates.
Researchers have been meticulously studying the fossils, and some believe they may have been the first Europeans, having migrated from Africa hundreds of thousands of years ago. The brain size of these individuals was smaller than modern man, and much smaller than Neanderthal. The question often asked is how brain size relates to intelligence.
The possible correlation of brain size to intelligence is an enormously difficult topic. We really don't know how well or how little it seems to correlate, particularly when we're thinking of it in paleontological perspective. There are lots of tests that are done every year. Some more recent testing has been done with a whole battery of intelligence tests with college students, and then doing magnetic resonance imaging, MRIing of the crania. And you can do that and get extremely accurate estimates of the brain size. And what they are finding, or have been finding, are correlations on the order of roughly 0.4 to 0.6 between brain size and these whole batteries of intelligence tests. This is sort of mind-blowing in a way because we've always assumed that there is no relationship between brain size and intelligence. And previous measurements had always given a correlation roughly on the order of 0.2 or 0.3 and not being very significant. So this new kind of data is interesting. The question is, you have tremendous degrees of overlap of brain sizes, and these correlations are low. So there is no way that you can look at a given individual, measure the size of the brain, and make a prediction of their intelligence. It just won't work. But to think of intelligence in the paleontological, paleoanthropological perspective, you're dealing with 3 to 4 million years of change. You find an increase that is almost triple in terms of brain size increase from the early time to our own time. So, I mean, intuitively, as you look at this archaeological record that accompanies that, in which the tools are getting more numerous, more complex, it seems obvious that there has to be some relationship between brain size and intelligence, at least in the paleontological perspective. But what do you do with a modern perspective? Because there are populations that do differ in terms of their brain sizes.
Rudolfensis, Erectus, Ergaster, Heidelbergensis. As the human family grows, we can look at possible lineages of human evolution, called phylogenies. The theories of mankind's family tree are periodically changing based on new findings. The most recent best guess will change yet again when future evidence gives us a clearer picture of our ancestry. Their lineage eventually leads to Homo sapiens, our species of human. Science is based on hypotheses, which are based on questions. Sometimes at odds with science is religion, which is based on faith. But the two need not be at odds.
Creationism has been a problem for those who try to teach evolution. In particular, those who study evolution don't have so much of a problem with it. And one of the big things that I think is very important for everybody to understand is that we are not comparing two authoritarian systems of knowledge here. Science is a matter of provisional knowledge, of refining that knowledge, of showing that what we thought in the past was somehow incomplete, if not wrong. So science is not really comparable to religious belief, which is based on faith, and science is based on doubt.
That concludes Part 2 of Early Man. In Part 3, we'll look at one of the most fascinating humans, Homo neanderthalensis, or better known simply as Neanderthal. Also, we'll meet those who peopled the New World. As we move into the modern era, we can witness the strides made in tool industries and the move from hunter-gatherer societies to the domestication of plants and animals. In other words, farming. Mankind is now at the dawn of civilization.